Afternoon. Can everyone hear me all right? All right, well, I have the pleasure of talking to you right after lunch today, so hopefully I'll keep everyone awake and entertained, and you'll learn a thing or two. My name is Wade Wegner, and I'm going to be talking today about Windows Azure and mobile applications. And we're going to be going through and talking about 4 of the more common scenarios and things that you need to be aware of, and how they particularly relate to cloud and mobile. And I'll be giving demos along the way as well. So I've got 4 different demos queued up to help try and reinforce and to explain some of these concepts. Now, one thing I do want to note is all of these demos are going to be talking to APIs running in the cloud, and they really could be any type of platform. So it could be iOS, it could be Android, it could be Windows Phone. Given that it's a TechEd conference and it's a little bit more difficult here to run multiple platforms and devices, I've opted to focus on Windows Phone. But I'm going to show you at the end of the talk where you can get some resources so that you can do the same sorts of things with Objective-C and Xcode, Android, and other clients as well. Real quick, I am the CTO at Aditi Technologies. We are a Microsoft partner focused in all things Microsoft, mostly on the dev side. We've got a lot of experience with Windows Azure. I've been at the company about 4 months now, but the company's been doing Windows Azure development for almost 3 years. We've been the partner of the year or the runner-up for the last 3 years for Windows Azure, so a very strong practice and strong competency. Prior to joining Aditi, I was the director of the director of technical evangelism for Windows Azure. So I focused on Windows Azure at Microsoft for about 4.5 years. I had the pleasure of building one of the keynote demos for Bob Muglia in 2008, and it all kind of went from there. I do a lot of blogging, so you can read up some articles and a lot of articles about some of these topics at my blog listed there. I tweet quite a bit, so you can follow me on Twitter and we can get into some conversations. And then all of these samples that I'm going to be giving today, I'm actually going to be putting up on GitHub after this talk. What I'm going to do is put the begin state for all the applications as well as the end state, so that you can feel free to try to do the exact same things that I do as well. So once this talk is over, I will commit everything up to GitHub, because then I'll actually have an end state. So you can take a look up at GitHub and you'll be able to get a hold of these samples. So again, we're going to talk about building device apps in Windows Azure and some of the concepts you need to be aware of. And specifically, we're going to be talking about storage, identity, communications, and some of the different platform services that you can use that make this a little bit easier within Windows Azure. And as I mentioned, we're going to have a few demos along the way. So these are the 4 different areas. Now, one of the things I want to note is there is a new capability of the platform that was released this summer called Windows Azure Websites. Now, Nathan Totten gave a detailed talk about this yesterday, and I actually showed a little bit about it in the overview. So I'm not going to go into depth on the websites topic in this talk, but I really want to emphasize the fact that Windows Azure Websites makes mobile development much, much easier, because you've got a place where you can do iterative development and deployment to continuously. So every time you build an API, every time you want to test it from your mobile client device, you can do a web deploy, you can do a git commit, you can do a TFS check-in to get your code up into Windows Azure Websites. So you can get almost real-time access from your mobile device in order to validate the APIs and the services that you're building. So Windows Azure Websites is a godsend for mobile client development. The other thing that I want to mention is that 2 weeks ago, Windows Azure released what's called mobile services. Now, initially, mobile services is focused on Windows 8. It's a set of services that, as a UI or UX developer with Windows 8, you can tap into these services to get access to things like data or authorization or diagnostics or notifications. Many of the same things I'm going to be showing you today. The difference is that you don't have to focus on the back end when using Windows Azure Mobile Services. The platform provides these back end services for you. All you need to do is build your application and leverage these services. Now, Nick Harris yesterday gave a detailed talk on Windows Azure Mobile Services. So if you didn't get a chance to attend it, I would encourage you to watch that session. I'm not going to be covering it here because I'm making the assumption that we all want to build the back-end services along with the front-end application. So I'm going to be talking a lot about building these APIs and building these services that get hosted up into Windows Azure. But again, this is something that you should really take a look at, because it's a new capability of the platform, and it's going to make, I think, front-end development much, much easier. And Nick said yesterday, Windows 8 is just the beginning. The plan is to provide explicit support for iOS, for Windows Phone, for Android, and other platforms moving forward. So let's start with storage. Now, within Windows Azure, there's a lot of different storage options. And I'm not going to spend most of the time talking about all these because hopefully you've got some grounding and background in this as well. But there's a lot of different things that you can take advantage of within Windows Azure. There's tables for non-relational and kind of structured data. This is great for lists of things, keeping track of type binary data that you've put up in the cloud and those sorts of things. There's also Windows Azure Blobs, which is a great place to put things like videos or pictures or images, these big binary files that you want to get access to. And what's nice about blob storage as well is that you can attach it directly to the Windows Azure Content Delivery Network. So from a mobile app developer's perspective, it's really good to be able to get this data as close to your users as possible, given that they're going to have a constrained bandwidth for consuming this. There's Windows Azure Queues, which allows for some asynchronous patterns between different parts of your application. So you can enqueue a work item into a queue and have some sort of back-end process run it. And then the last thing to cover is Windows Azure SQL Database. And Windows Azure SQL Database is a relational database service that you can use. So what you're familiar with SQL Server applies to Windows Azure SQL Database. You can create stored procedures. You can create tables. You can create unions between tables. You can create aggregates, all those things that relational databases do really well. And you can use SQL Database up in the cloud. So these are some of the options for storage that you can take advantage of. Now, what's interesting about storage with mobile apps, though, is anytime you access one of these storage constructs, you need to provide some kind of secret in order to get access to it. So if you're going to connect to SQL Database, you need to have a connection string. And in that connection string is a user ID and password. If you're going to get access to Windows Azure Blobs or tables, you have an account name and an account key. And so you need to provide those as part of the request signature so that it authorizes you to access this content. And so this presents a dilemma for a mobile developer because we want to keep these secrets secret. We don't want to put them on the device. So it introduces some different challenges and paradigms that we're going to talk through. So just to emphasize this again, with Windows Azure, if you take a look at the storage accounts for Windows Azure Blobs or tables, you will have an account name, and you're going to get this key. It's a long hash. And these two pieces end up signing your request every time you interact with the storage service. And if you don't have a valid request that's been signed by this information, the storage service won't accept the request. So this information needs to be somewhere. And the same thing with a connection string. You need, if you're going to communicate to SQL Database, you've got to have the valid credentials, or else the TDS endpoint will not authenticate your user. So again, the point here is that if you put it on the device, chances are someone's going to get access to it. So you don't want to put these secrets into your application on the device. We've probably all used the app.config or a XAML file for resources and so forth and put these types of things in the app. But if there's one smart end user out there that wants to do something to get at this information, they can probably find a way to do it. So the best bet is just not to do it at all. And so we end up keeping these things secret by doing different patterns such as proxying the requests to storage. So I'm going to walk through a couple of diagrams here to try to showcase what this looks like, and then we're going to have some demos to show exactly what I mean. So in this scenario, we've got a mobile client that we've written, and we are not going to put the keys on that client because we don't want them to get out. We've got a web role, or just a web application running up in Windows Azure, and this is going to front all of the requests we have to storage. And also we have up there, we've got either tables, blobs, SQL database, it doesn't matter. So the very first thing we'll do is the device, instead of going directly to storage, is going to go to our service. And our service is actually going to be a gatekeeper to the back-end data that we want to get access to. Our service is up in the cloud, and it's segregated from all the other users. So it's OK to put our storage secrets into that service. So our service is secure. We can put our secrets there. So that way, our service can make the request back to the data store that we want to make the request from and actually get access to those resources. So it's just a very simple proxying over our data so that we don't have to put the secrets on the device. Same sort of thing happens with SQL Database. We end up having a service that fronts the request for our mobile application, and it's going to make the request back to the database for us. And then, of course, it can end up returning some results, and then we can pass it back to the mobile device. So very, very simple patterns. In practice, though, a lot of people have some confusion and some questions about how this works, particularly when you're dealing with large binary data. Imagine you take a picture or video from your mobile device. You may not want to push that through a proxy in order to get back to the backend data store, because that's just going to take additional time. There's multiple hops now, and you have an intermediary that's slowing things down. So with Windows Azure Storage, you have the concept of a shared access signature that gives you a way to let your device or your client talk directly to storage even though it doesn't have the key. And I'll show you how this works using shared access signatures. So we have our web service running up in Windows Azure, and we've got our backend data storage. What's going to happen is the device is going to call a service of ours, and this time, rather than sending the data with this first call, all we're doing is a simple get to a shared access signature service and asking the service to give us a shared access signature. Now, a shared access signature, and you'll see it in a moment, is nothing more than a URI that's got some data in the query string along with a hash. And this data is enough, then, for us to make the request securely to the backend data storage. So what happens is the service will send back to the client this URI, this shared access signature. The client then, if it wants to send information or even read information directly from storage, uses that shared access signature to access storage directly itself. So this is a way that we can get secure access directly to storage without having an intermediary or a proxy in between, but in a way where we don't have the secrets on the client. So let me go ahead and show you exactly what this looks like with the first demo. All right, so what I've got here is I built a very simple application. It's a ASP.NET Web API project, so it's part of ASP.NET 4. And what I've done is created a project, and I'm using the Windows Azure Storage library as well. So if you take a look at packages, one of the things you'll note here is Windows Azure.storage is a NuGet package that I've pulled into the project. Hopefully everyone here is familiar with NuGet. It's a package manager for .NET, and essentially it allows me to get access to a client library that I can use to interact directly with Windows Azure Storage. Now, I'm not going to spend too much time going through the specifics of this API because it's not really the point of this talk, but what I want to show here is how simple it is to build out a simple API service that's responsibility is to pass back a shared access signature to us. So what I've got here is a couple of methods called get, and then I've got a get with blob name content type. Typically, you'd probably just want this second one because you want to know what is the name of the blob that you want to upload, and you also want to know what the content type is so that you encode it properly. But given that I'm going to be showing some of these demos through the browser, I just went ahead and created a method as well that expects no additional parameters being passed to it. Now, it's pretty straightforward. Let me go ahead and expand this a little bit. What you'll see here is the very first thing I do is I'm going to access my storage account. And this is done right here. You can see how we create a storage account, and we're using information that I'm just storing right now within the method. Now, you would most likely want to put this in an app config or your CF/CFG file with Windows Azure. For the sake of the demo, I've just put it right here for you. So I've got my account name and my account key. Now, these, again, are in the service, so they're not accessible to the client at all. They're in the service. So I'm going to create access to my cloud storage account as well as the blob container. And what I'm going to do here is create a shared access signature policy. Now, a policy defines a period of time with which someone can either read or have write access to the storage service. And by creating this policy and attaching it to the blob container, what I'm essentially doing is saying that for a period of time, this user is going to have access to these resources. And you can see here that what I've got is for the shared access expiry time, it's going to be for 4 hours. Now, you probably don't need it to be set to 4 hours. You could make this 4 minutes. You could make this 24 hours. It's really up to you. But what it's going to do is at least give me access to these resources through this policy for a period of time. Now, what's nice about having the policy is, let's say something happens and these URIs are set for 24 hours and they get out into the wild, and people that I don't want to have access to them get access to them. You can delete the policies, and as soon as you delete the policy, anyone that tries to access these resources using that information will be denied access. So just a little bit about policies there with shared access signatures. Now, the last thing I do is on the blob container, I'm going to say get that shared access signature value based on this policy. And I get this SAS value back. And then all I'm doing down here is taking the blob URI name, the blob name, and the shared access signature, and I'm constructing a URI that I'm going to pass back to the client. So let me show you what this looks like when it's run. So I'm just running this locally, but it is going to be communicating directly to Windows Azure Storage Service in order to get this shared access signature. And so I'm going to go to API SAS, And you should see here in a moment that I'm going to get a URI for this application. Now, do I have a breakpoint in there? Well, while that's going, what I'll do too is here I've got this container. And the container by default actually looks like the network is not responding for me very well. What's that? Did I sacrifice a goat? No. OK, well, this returned, so hopefully that means that it's just warming up. There we go. OK, good. So, so the service, you can see now, has returned back this URL, this URI. And let me copy this. Now, the reason I want to copy this is if I paste this in and make the address, you'll see that I get back this image right here. And this is getting an image out of my storage service, even though the container that the image is in is actually set to private. So if you take a look at this media folder, we can see that from a policy perspective, well, right now it's set to read-only, but if I set it to private and click OK and look at the skier's picture, if I try to access this directly, I shouldn't have access to it. Oh, come on, IE. There we go. So you can see that I can't actually access that resource. But using that shared access signature, though, I'm able to access the resource because I've passed in an information that includes a signature right here. So this is a value that is generated based on the account name, the account key, and these additional policy information that's passed into it. So by getting that, then the storage service is able to decrypt that signature and validate that I am who I say I am, and I should have access to that resource. So shared access signatures are a way that we're going to use quite a bit in order to get access to resources in ways that we don't have to put the secrets on the client. So that's the first demo that I wanted to show. It's very simple to build these things. There's a lot of resources and examples out there that you can take a look at. And like I said, I'll actually have this checked up into GitHub at the end of the day so that you guys can just grab this as well. So let's flip back. And I think actually, yes. All right. So I actually have another demo. So coming back here, what I want to do now is say, let's move beyond this simple example and build out a Windows Phone application that uses this in practice. So I'm going to go ahead and close this for now. And I have set up just the basics in the beginning of an application. Right now, this application doesn't really do much of anything. I've just got the pieces in place. Let me run it, and I'll show you what it does. It's going to let me use the camera capture task to take a picture on the phone and essentially get access to the pictures, the stream of the picture, and I'll be able to do something with it. Right now, I haven't wired that up yet. So I could give it a name. So I could say like 1.jpg. Click this upload button, capture a picture, accept it, and then we'll do something with it. So that's not wired up yet. So let me go ahead and wire that up. So essentially what we want to do is you can see right here, the stream is going to be available as part of this photo result. So we want to grab that, and the first thing we want to do is upload it into blob storage. Now I'm going to go ahead and use a NuGet package that Microsoft provides to do much of this. It's called phone.storage. And this gives me a lot of the APIs I need so that I can start to interact with the storage service from the mobile client. Now before I start doing it, one thing I want to point out is this storage initializer. By default, there's this concept of a resolver, so that from a development perspective, I don't have to worry too much about how I'm accessing the storage service. I just know that I'm accessing the storage service. By default, it's set up to use local development storage. So you can see down here, I've got the storage emulator down here running. And so what happens is, by default, when I develop against this API, it's going to use the local storage service. Now, when we get ready to deploy this, of course, we're going to want to change it so that we're not using the local storage service, we're using something else. And we'll get there eventually. But we'll come back here to the storage initializer in a moment. Now that I've added that, one of the first things I want to do is create a Lambda expression that allows me to take the stream, the image stream, and upload it into blob storage. And since this is only an hour-long presentation, I've got some snippets to do this for me. Plus, it's quite a bit of code. I don't want to have to write it and make a whole bunch of mistakes here. So let me go ahead and add some of these things, and then I'll explain just exactly what this is. I think this is actually image name. Yeah. And all right, so if we take a look at this, what we've got here is, we get the storage, cloud storage context. We are going to reference a container name that we're going to call Pix. Now pix is going to be where we're going to put all the images. From the text block, we're going to grab the image name that we put in, and then we're going to say create if not exist, which means create the container if the container does not exist. And then essentially we're going to pass along the image name, which is going to be used as the blob reference value. It's going to pass the stream in, and then it's going to upload it as part of that. Now, once it's done, it's going to then execute whatever is within response 2. So once we've uploaded it, we actually want to create a pointer to the image that we've uploaded. So we want to write a record to table storage, and then that way we can eventually query table storage to see what images we have, and we can use that as a way to get to the images that we update. So I've got another very quick thing here that's going to let me create the table client. And very similar pattern here. We're going to create the context for it. We're going to create something called sample data, which is going to be a combination of our name and our URL, and then we're going to go ahead and write that up into storage. So when we're done with this, we're going to have the image that we've taken from the device up in blob storage, and we're going to write a record for it out in table storage. So I just need to create the sample data. And these snippets make it super easy to do these demos. It makes it look like I know what I'm doing. So I'm not going to spend too much time. Hopefully you guys, if you've used Windows Azure and storage, are familiar with this. Basically, we create a class that inherits from table service entity, and it knows how to appropriately read and write these records based on the partition key value and so forth. So again, I'm not going to spend too much time here since I want to focus on the mobile aspect of things. So this is enough now to grab and upload the image. Now the one last thing that I want to do here is I've got this very simple list items page, and I want to use this as a way to query table storage and then populate a set of list items so that we can see what values we've uploaded. And so there's just like I said, a very simple list block right here, and then back here, once it loads, we're going to end up doing a query. And again, it's going to use pieces of the API from the phone.storage NuGet package. And what we're going to do is essentially grab that sample data, pull it out, load it into a Cloud Notes value. I don't know why I called it Cloud Notes. But essentially, we're going to then bind it to the item source. And we're going to go ahead and load that asynchronously. So you guys can take a look at GitHub to get access to this code a little bit later. Let's go ahead and run this. So now, as this is loading, what I want to also do is I'm going to open up a storage explorer that's going to show me my local dev storage. And we'll see here, right now, we don't have any pictures loaded. And we also don't have any pictures loaded here in lists. So this is against the storage emulator. So I'm going to go ahead and say pic1.jpg. Now, for those of you that have used the Windows Phone emulator know that it doesn't take very exciting pictures by default. But we've taken it, we've now grabbed it, and it's uploaded it to blobs and written a record. So if I come into here and do a refresh, you'll see here's pic1. And if we open this, you can see here's the picture that the emulator took. Similarly, here in table storage, if I do a refresh, you'll see that I have access to that record. So this record here gives a name, which is pic1jpg, and then a URL, which can be used to address it within blob storage. So that's the information that we're going to use now when I come here to view all, which takes us to the other page, which binds that data to the list items. So very, very simple demo demonstrating how this works. Now, we are talking from the phone client directly to our local storage, which is exactly what I said we shouldn't do, because if we go to switch this to a deployed version of the Windows Azure storage, then we have to put the secrets on the device. So this is where we come back to how we initialize storage. So let me go ahead and make sure this is no longer debugging. And I'm going to add an additional project here. I'm going to go ahead and add, let's see, do I want to create, should just work fine. I'm just going to create an MVC4 app. And we'll just do a basic internet app, that's fine. And I'm going to take advantage of another NuGet package which has built into it a shared access signature service that we can leverage from the phone. So what I showed you in the previous demo that returns a shared access signature, Microsoft has provided a NuGet package that we can use that does most of this already. This is called the Windows Azure .storage. Let's see. Oops, sorry. I think it is, yeah, Windows Azure. Is it storage proxy or is it just proxy? Nope. All right, I'm having a brain fart here. I thought it was storage proxy. Yeah, I usually, I do need to switch that, but it should still list out the right packages. And now Visual Studio is busy. All right, well, while that's coming back, the point of this is now what I want to do is lay down a couple of services in a web project. And the web project has the shared access signatures service in it. So now the phone, instead of going directly to storage, is going to communicate to these shared access signatures so that when it comes time to upload the blob client as well as write to table storage, it can do it through the through these services instead of communicating directly to the storage service itself. And I really don't know why Visual Studio is not replying. Now let me close this real quick. Let's try this again. New project, EC4. And for those of you wondering, I did actually validate this ahead of time, so I will switch this to the MVC app, install package. What is Azure? Every time I hit the tab button, Visual Studio no longer complies. All right, so I will try to come back to that. Apologies about this. We'll see what's happening here in a moment. I'm going to go ahead and move on. But I don't want you to miss the point of the demo, which I think is actually really important, is that creating a separate web project allows us to have the services needed in order to get the shared access signature we want to be able to write directly to storage. So we'll come back to that. I'm sure it will work at some point. I've done this demo at least a dozen times. So, all right, so moving on to identity. Now, identity is another one of those topics that's actually really important for you to think about ahead of time when it comes to building a mobile application. And the reason is it's actually really tricky to keep track of identity for your mobile clients. There's a lot of different ways that you can go about doing it. Many services will actually create their own identity stores, which means that when a user comes through your app, you're probably asking them to create an account, specifying a username, a password, and setting some additional data. So there's complexity involved with this. You also have to find the right model in order to go about doing this. You might use a provider model that comes with .NET and actually write this to, let's say SQL Azure, and keep track of users and usernames and those sorts of things. But then you also have to keep track of how do people recover their password when they've forgotten it. How do you keep track and make sure that all this data is staying secure so that you aren't the latest tech story about all this private information being hacked into and shared publicly. So rather than rolling your own, a lot of people then choose to use an existing identity provider. So you might use something like Facebook or Live ID and program directly to that identity provider's API. And this works really well. Most of us here have probably used Facebook or Twitter or something like that in the past. But part of the problem and complexity here is now you're directly programming your application against this provider's API. And so if it changes, you need to make sure that you are also updating your application to take advantage of these changes. And if you've used Facebook in the past, you know that this actually can be quite a bit of work. Facebook for a period of time was changing the way OAuth worked almost weekly. So that's, although it's an option, there's also a third option which I would argue is a little bit better, and this is to outsource identity management entirely and take advantage of claims within your application. So your application is actually set up to work against these claims rather than the specific identity provider your user is using. So let me just reinforce a couple of these things. So when it comes to an application and an identity, you're going to have some sort of authentication and authorization you need to do. There's going to be a store of users somewhere. You're going to have to protect the data, management, forget password, support, all these different things that you're going to end up having to do. And this is quite a bit of work. And there's a lot of different points of entry where people can attack and try to take advantage and compromise your system. So the quote-unquote nirvana when it comes to a mobile app and this is actually true even for a lot of cloud-based applications as well, is to move towards a claims-based architecture. Now, with the .NET stack, this is actually pretty straightforward because we can take advantage of the access control service with Windows Identity Foundation. Now, the Windows Identity Foundation is specific to .NET. The access control service is not. And the access control service can communicate through another number of different formats, including simple web tokens, which is essentially an OAuth token that you can use within your applications. It's very easy to consume, very easy to use, and I'm going to go ahead and show you how we can do this in this next demo. So let me flip over. Okay, so I have lost the network. Let me see if I can connect again to the network. And what I'm going to use is the Windows Azure portal, and I'm going to set up a service namespace within the access control service. No internet access. In the back, would you guys be able to have someone check on the network? I'm going to switch over to the conference network. And it might be a little bit slower, but maybe it'll actually work. Apologies, everyone. It's hard to do a cloud demo when it comes to when you don't actually have the network access. So I think this is TechEd 2012, if I'm right. I did a keynote in Netherlands with Scott Hanselman and lost the network in a 5-minute keynote presentation twice. So it was really awkward. It was my first keynote in front of thousands of people. And I think I got more sympathy than anything else. So, all right, let's give this another shot. Hopefully we're up and on the network now. All right, good. So I'm going to log into Windows Azure. Now, yesterday, if you came to the talk, you probably heard me say it's very easy to set up an account. There's a free trial that's capped, so you actually won't get charged if you want to use it. And since I'm using the access control service, I actually can't use the new preview portal. I need to go to the older portal. So I'm going to go to the evil portal, which is the Silverlight portal. It's actually not evil. It still communicates against the same APIs you have access to, but it actually has access to the access control service that the newer portal does not yet have. So we got to go through the new portal. And what I'm going to do is go to access control. And you can create a service namespace, which becomes your piece of the access control service pretty easily. It only takes about 2 or 3 minutes. But rather than wait, I created a new one here. I haven't done anything with it, so we're going to modify it together. So I'm going to go ahead and I click the access control service here. And what we're going to do is go ahead and configure the access control service so that it can handle the different identity providers we want users to use and hand our application a simple web token, which again is just a OAuth bearer token that we can use within the app. So the first thing we do is we configure some identity providers that we want to use. I'm going to add Google. I was able to switch over to the conference network, so I'm good for the moment. And I'm going to use Yahoo. Now what's nice about this is I'm adding these identity providers. I could also add Active Directory through ADFS. So if you wanted to use corporate identities, you could use corporate identities through ADFS. And even though I'm using these different identity providers, I'm going to be using a same set of claims for all of them. So from an app dev perspective, I don't have to take into consideration all the nuances of these identity providers. The access control service does that for me. Now the next thing I need to do is create a relying party. And the relying party is really just going to be the way I configure the service namespace for my application itself. It's going to specify a URI that I'm going to use. And this is just a way to address the realm that we're interacting with. I'm going to tell it to return a simple web token, and I'm going to have it generate a symmetric key that we're going to use. Now, I'm going to copy this symmetric key because we're going to use it later. I'm just going to put it right here, and I'll explain why I need it later. I'm going to go ahead and save that. So this creates the realm and the relying party that I need for the application. We're going to use that within the application in a moment. So let's let this save. Hopefully still have network access. And I don't. Wonderful. All right. replace it. There we go. Okay, so was able to create it. So we do have our relying party configured. Last step we need to do is actually set up the default rules. The default rules dictate how the claims coming from the underlying identity provider, like Google or LiveID, map to the claims that my application uses. So by default, there's some rules that we can just generate, and it will just use the defaults. But you can change this and use this yourself as well. And there's a lot of information and some advanced topics around access control service that you can take a look at that you can use within your application. We're just going to go ahead and use the defaults. In terms of configuring ACS, that's all we have to do. It may seem like a lot. It took longer than usual because we had some network hiccups, but that's it. Now we can actually focus on the app and how we're going to use this. So now the app, what I've got is a very simple app. Right now it doesn't use identity whatsoever. So let me go ahead and start and run this, and I'll show you what I've built. Basically, I've got a web backend that's an API layer that's got a controller that returns back a list of beers. And for those of you that actually know me, you'll know that oh wait, this is the wrong project. Let me open the right project. I didn't see my beer controller, and I wondered what happened to it. All right. So I'm an avid home brewer, and so my time here thus far in New Zealand, I've spent taking a look at some of the different microbreweries here in town. And so I've created a beer controller that lists out some of these beers. So you can see here, there's the Dogberry Pale Ale, some other ones. One that I tried last night that was really good was the Custom 69. So basically, it's a very simple controller, and when I run it, it's just going to return back and bind to my app just these lists of beers. What I want to do in this app is actually secure that endpoint so that you have to authenticate and pass the OAuth bearer token, validate that OAuth bearer token within the API before you turn the result back. So we're going to go ahead and do that right now. The first thing I'm going to do is within the phone, I'm going to actually wire up the access control service. And so I can use a NuGet package called phone.identity.basepage. And if the internet's working, this should, I'm hitting tab if you guys didn't realize that. Tab actually auto-completes. And so I'm going to hit that and go ahead and install this NuGet. And what this does is it's going to install some API, a library that we can use to interact with the access control service, along with a base page that's loaded right here that's going to handle all the login for us. And so I want that to load first, so I'm going to come here to the WM app manifest, and I'm going to just say first load pages/login page. And then in the login page, we need to know what to do once you've logged in. And so I want it to go back to main page and down here as well. So once you log in successfully, we're going to go back here. Now the last thing I need to do is specify what the access control service namespace is we're going to use along with the realm. And so that's what we just set up before. And so that is TechEd New Zealand 2012. And the realm is, you guessed it, URI phone. All right, so that now will give us a login experience from the phone. Essentially what we can do is take a look at this main page, and you can see here is how I address the API that I wrote. And what I want to do is actually essentially take the token and use that token. So we've got a little snippet here that lets me get access to the simple web token that we're going to use. And this is part of that NuGet. And essentially out of the resources, it grabs the simple web token that represents our application. So let's stop here for now, and let's go back to the web app, the app itself, or to the API. And what I want to do is modify the API so that only an authenticated user can get access to it. I'm going to use something called a delegating handler within the API. Now, a delegating handler is really handy because what you can do with the delegating handler is get access to the request before it loads the context of the request. So you can actually take a look at the request header. You can look at some of that information before the full body of the message, the request is loaded. So it's very performant from that perspective, and it gives us a great place where we can validate all the aspects of the application, or of the request before we end up processing it. So what I'm going to do here is add a message handler called token validation handler and create this class. And basically, what this does is it's just going to use delegating handler, which is part of system.net HTTP. And there's a method here called send-to-async. And essentially, send-to-async is what we're gonna use to intercept the request and make some decisions. So now that we've done that, the first thing we want to do is grab a bearer token out of the request header. And so the bearer token is kind of the industry standard for the OAuth. It's how you refer to it. And you can see here we're going to say look in the header, the authorization headers, and if this is not null, go ahead and grab the authorization value and set it to the auth header. Down here, what we do is we have this header, which represents the bearer token. And so it's by convention, it's prefixed with OAuth space. So what we're going to do is do this ordinal comparison and remove the OAuth from it. Well, actually, first we're going to check to see if it has that. Because if it doesn't have that, that means that the bearer token may be in a different format. And we're expecting an OAuth token. And so we're going to do that and remove this header from it. And what we're going to be left with is the token itself. So that's the token we want now. Just getting the token doesn't mean that it's actually a valid token. So someone could have constructed something that looks like a token and passed it to our service, and we don't know that it's valid. So before we do anything else, we want to validate that that token actually came from the access control service and is a valid token. And we're going to do that using a couple of a thing called a simple web token validator. Now, this is another package, and I'll show you what it uses. But it's a package provided by a gentleman named Matthias Walensky. He works for a company called Auth10. I used to work with him actually quite a bit, but he's created this simple web token NuGet package, and in it is, oops, sorry. Switch this over here. In it is a method that we're going to use that's going to validate the token. Now, the way this works is it's very similar to the shared access signature. Before the token is going to end up getting signed by the access control service using a shared key. And that shared key is what I pasted into Notepad right here. So I'm going to grab that key and I'm going to put it in my service. Now that means that my service has access to that shared key as well. So I can end up using it to check that the token passed to me was signed, in fact, by the access control service. So it's the same way that the shared access signature for Windows Azure Storage works. It's actually just kind of the opposite direction. We're checking to make sure that the key is valid that was passed to us. So I'm going to go ahead and compile this. Oops, sorry, I got to add the reference. And I'll show you real quick this method and really where it works. You'll see it does a number of checks on the token, but it's down here where it says, is HMAC valid? It uses the key that's passed in, and it'll essentially create two different byte arrays. And then it'll do a comparison of those byte arrays to make sure that they're equal. If they're not equal, then it means that the token that was sent to us was either not signed or it was signed by a different shared secret. And if that's the case, then we don't want to use it, and we don't want to trust this token. So it's a very important step. Just getting the token itself isn't enough to validate the user. So we've done all of this. The last thing that we want to do in our application is make sure we pass along that token. So I'm going to come back to our main page here. And where we attach the, where we construct the request, I'm just going to add this request header right here, which basically says, you know, here's the authorization header. Here's the bearer type that it is, so it's OAuth. And then we're grabbing the raw token out of that simple web token store. So if all works, what I'm going to do is first run the web backend, and you'll see that it'll actually fail and it'll catch. And I'm doing this on purpose because by default it's hitting that URI through the browser, and the browser is not passing that request header. So you can see the error is exactly what we want it to be. The authorization header was invalid. So we know at least that from a browser this has been locked down and secured. So the next thing I'm going to do is run the web app itself. And let me put a quick breakpoint in here for us and run the phone. So now when it goes to load, it's going to grab that token once I log in. I actually have to log in first. And let's see, wait, TechEd. And yes, I did create a new one because you're going to be able to see the password as I type it. So it's going to sign in. You'll know that this is the first time I've done this because it should ask me to approve the service namespace with the access control service. I hope they're still network access. Well, I'll tell you what's happening. Right now, it's taking the credentials that I signed in with. Google is going to create its version of a token, pass that token over to the access control service. The access control service will run through the rules that we set up, transform it into the simple web token my app expects, and then pass it down. That's theoretically what it should be doing right now. And once it's done, then we have access to that token, and we can attach it to the requests that we make. Go back to Epsom now? Okay. Has anyone else been having flaky wireless access to the conference? Okay. All right, let me, well, I hope you guys forgive me for the wireless problems. I yesterday had absolutely no problems with it, so let's try this one more time. All right, that's good. So that means we got the home realm discovery page from the ACS service. Let's log in again. All right, good. So I'm going to allow. This only happens once, and you actually want this to happen. You want your users to make sure that they authorize this service. And you can see here now we've got that simple web store, and here's that raw token. And you know, I'll quickly, well, here, let me go back. There. Well, you can see that token is it's really just it's a string that comes back, and we're going to grab information off it, and we're going to attach it to the authorization header. So when it runs, it's going to end up passing that along with our request, and you can see we get access to those resources as they come back, because the API used the delegating handler to first parse and validate that token before it sent the response. So yeah, that's it. Hopefully that adds a little bit of, shows you guys a little bit how you can use those tokens. Again, all of this, use .NET and C# to do it, but there are libraries out there that you can use with Objective-C and Xcode so that you can do this with an iPhone app, and you can do the same thing with an Android app. And I'll show you those resources at the end of the talk. All right, so that wraps up identity. Quickly, we're going to talk through some different forms of communication. When it comes to a phone app, there's really two different types of communication. One is initiated by the user and through the app, and you can think of this as kind of a pull. This is very traditional type of interaction where your app will call out to a service and return some data. You just saw that in the last demo where the phone called out to a service and got a list of beers back. So that's pretty typical. The other is cloud initiated, and this is when we get to push notifications. And hopefully you guys got a chance to see Nick Harris talk yesterday about push notifications with Windows Phone and Windows 8. He went into a lot of detail. I'm going to show some things as well, but the push notification provides a lot of benefits because it allows you to send a signal and send a message to the device without waiting for a user to first request it. Now, when you're looking at both device as well as cloud-initiated messages, there's a number of different formats that you can end up using. First of all, they can be HTTP-based. They can be request response. There's a lot of different frameworks you can use: WCF, Web APIs, OData, traditional XML, and so forth. And then there's different types of formats as well, wire formats. And I'll make the statement that the wire format you want to use when it comes to mobile apps is JSON, and that's because you can effectively describe your payload with less verbosity than with the other formats. So consider here is an XML or a OData XML file that describes a payload, and it's 8.5 kilobytes. If we represent it as just REST XML, it ends up being 1.2 kilobytes, and JSON, the exact same data coming back, is just 639 bytes. So you can really decrease how verbose your message is by choosing the right wire format. And if you've done any exploration of the ASP.NET Web APIs, you'll know that all these different format types are supported, and it's a function of the request to choose which type of response that you want. If you recall, I didn't point this out, but in the request header, when I constructed the request, I actually set it to JSON as the response type as part of my request. I basically told the service, I expect you to send me some JSON back. And JSON is one of the more effective ways for communicating across the wire. Now, push notifications are useful because, again, you don't need to wait for the client app or the user to initiate the communication. You can actually send a message down to them. And there's a couple of different types. The first is a raw message type with Windows Phone, where you can actually send a message and push it directly into the application. And I'll show an example of this in a moment. You can also send toast notifications, which you can see in the image there, where it pops up a toast indicating that there's something to do. And you can also send tile notifications, which can either change an image on a tile, it can change the back image on a tile, it can add a number, you can change the title, a lot of different things. And so you have a lot of different formats and a lot of different possibilities with push notifications. Other notification providers, such as the APNS for iOS apps, C2DM, as well as the Windows notification service, also support different types of notifications. And it's all dependent on the provider. And there's different ways in which you construct the message. Now, the model for all these notification services and how you go about registering these channels and getting this set up is pretty uniform. The way that it works is the application you build, so the client app, will first go to the notification service and say, I want to create a channel URI that someone's going to be able to use to send me a notification. So this is an opt-in model. So you contact the notification service, say, give me a channel URI. The notification service will return back that channel. And that channel, again, is really just a unique way of identifying your app, and that device, so that you can send a message directly to it. So when it comes back, now your application has this channel URI, and you need to do something with it, because you need that channel URI in order to send a message to that device. Typically, what you'll end up doing is storing that channel URI somewhere else. And with Windows Azure, it's pretty straightforward to just take that channel URI and store it either in SQL Azure or in Windows Azure Table Storage. I've been doing this for a long time, just using Windows Azure Table Storage, and it's worked great. Once it's stored, that's the first step, right? Now we've opted in and created a channel URI that our application from within the cloud can use to address that phone and that device. So once we've got it now, I can create a service that uses that channel URI to send a message through the notification service, and the notification service will deliver that message on the device. Now, the reason we don't send it directly to the device is, first of all, you don't want to have a lot of different sockets or ports on the phone or the client listening for messages. That's what a lot of services and servers do, and that could end up, consuming a lot of bandwidth if you had a whole bunch of apps listening for messages. It also becomes unwieldy for the user to keep track of all these things. So the way that most devices work is they only work with the notification service for that platform. So you do end up going through it. Now, some cases like the Windows notification service, before you can send the message, you also have to auth to the notification service. So just be aware that based on the notification service, the model may be slightly different, but for the most part, the model and the pattern is the same. Now, one thing I wanted to note is there is a way to combine both cloud-initiated and device-initiated communications. And the reason this is important is when you send a notification to a device, the payload that you can send is usually pretty small. You can't send a whole lot of data. You may be able to send a line of text or something, but it's pretty constrained in terms of how much information you can send. And let's say you're using a language that you need to encode with like UTF-8 or in some non-ASCII language. It actually means that you can send even less information because that encoding takes up so much space. So a lot of times what you can do is send a pointer. So you send a little bit of information to the device, and when the user responds to it, you can have your application call out to a service to pull down the full message. So combining these two patterns together becomes an effective way to actually initiate something that your user responds to and then actually sucks down the entirety of the message. So I just walked through it, but basically you can see here, you send a message to the device, then the user ends up making a call and getting that data back. So there are a number of different notification services for each of the platforms, and I'm going to go ahead and show you how this works with Windows Phone using some of these things. Now, I did go ahead and set this one up in advance because I figured I would be running short on time, and I am. So I'm going to open it, and I'm going to show you, I don't know how my email opened. I'm going to show you what this is doing here. All this is available through a couple of NuGet packages, and you can actually get access to the source code as well. All the source is up in GitHub under the Windows Azure GitHub user account. And you can see I've got two different projects. I've got my phone project, and I've got a web project. Now the web project, what it's doing is two different things. One is it's handling the sending of messages to my client. So it's got some plumbing there to extract a channel URI from storage and send a message to the client. And then the client has got some code and plumbing that will create a channel. So it'll allow me to subscribe and open a channel with the Microsoft Push Notification service. And then it will send that channel URI to the service so that it can store it somewhere. So just exactly what I described has been set up here. So let me go ahead and run this. And I'll start off by running the web app here. And this is just a very simple MVC application. It's actually using an MVC area as well, so that we have a place to generate the notifications and send them. So if I come here to /notifications, this is an MVC area that's really been set up mostly for development purposes, so that we can test that, make sure that all this stuff works. So got that running. Now let me open up my phone app. Now, if you want your Windows Phone app to actually get into the marketplace, you have to let the user opt into giving you your channel URI. I've actually tried to submit an app to the phone marketplace that automatically opened up a channel URI, and it was declined. So I do know that they have that as part of the validation testing. So somewhere you're going to have to give a user an option kind of like this. By default, notifications aren't set up, but you can enable them. Now, when I click that enable button, what it's actually doing is going off to the view model and saying, go ahead and go to the Windows Phone Notification Service, request a channel URI. Once you get the channel URI, then it sends it up to the Windows Azure service and stores it in Windows Azure tables. So you can see here it was able to successfully create that notification service. And I can validate this by coming here into tables. And if I refresh, you can see here I've got this channel URI that was just generated 15 seconds ago, so not too long ago at all. And now if I refresh this page, you'll see it's going to display that channel information right there. So let me go ahead and shrink this a little bit. Now what's nice about this app and this scaffolding here is I can use this to send a notification. So we can validate that this stuff is actually working. So I'm going to first send a raw message. So I can say hello out there and send this. And you can see it was sent it, so it was received and accepted by MPNS. And then over here, we handled that raw notification. So raw notifications are pretty nice because the application can accept the message directly and then do something with it. In this case, we displayed it within the application. We can also validate that tile and push works as well. So if I go ahead and pin this to start, I can go ahead and send a tile. Now there's a lot of different options with tiles, so I can end up changing the title. I can say hello. We can send down a number if we wanted to indicate missing three messages, and we can also end up sending down an image as well. And so we can send this. MPNS accepted it, and in a moment we should see it reflected here, and you can see the tile was in fact updated. And lastly, I can end up sending a toast. And you can set some properties with that as well. It should send a toast down to the client. And what's nice about the toast then is if the user selects it, it'll actually open up the app. And here is where you could actually handle that event and do something, call out to a service and pull down some additional information that you might want. So that's an example of how a mobile client interacting with services and storage up in Windows Azure can be used to work with notifications. And the network didn't go out on me that time. That's great. All right, so lastly, we're going to close just by reviewing and taking a look at some additional services within the platform that can be used for mobile applications. And these are referred to as application building blocks within the Windows Azure platform. And there's a lot. We've covered some of them like storage and identity, but I want to talk about a couple of other ones. First is media services. Now, Nick Harris is going to be giving a talk tomorrow about Windows Azure Media Services, and that's a transcoding service that's available to you up in the cloud. So if you've got a video and you want to transcode that to a bunch of different formats so that you can play back natively on different devices, you can use that transcoding service. So imagine a case where, using everything I showed you here today, you captured a video stream, handed it off to the media service, it transcoded it into a bunch of different options so that it had native playback for an iOS device, an Android device, Windows Phone, you name it. It also can attach to the CDN and allow it to use smooth streaming. Smooth streaming is a technology that will actually encode and chunk up things such that it can progressively give your app something to progressively download so that it can most effectively run the video at the bit rate that's optimized for the channel. So you can get the best playback experience using something like smooth streaming. So definitely, if you're interested in this, take a look at the media services talk tomorrow, because that's another service that's really valuable. There's a whole set of messaging services within the service bus that can give you some different asynchronous patterns that you can use so that you can have some apps running in background services like worker roles up in Windows Azure. So you can consider a case where you may do something in an app that kicks off a job that runs in the background. So your device and your UI is not attached whatsoever to this running process. All you've done is written a message into a queue, and then somewhere else, a worker role or some other process has pulled it out of the queue and does something with it. So that's messaging in the service bus. There's the Windows Azure Traffic Manager, which effectively gives you DNS load balancing both within a data center and across data centers. So you can use this so that when you go to address one of your service endpoints, you can ask the traffic manager to send your users to the closest data center based on where they are. So you can get optimal performance. That means that you can run your application somewhere in North America, somewhere in Asia, and somewhere in Europe, and based on the locale of your user, it will route them to the nearest data center. This can also be used for some disaster recovery type scenarios as well, so that if a data center or a service were to go down in a data center, Global Traffic Manager could push you to one that's still up and running. Let's see, what else? I think probably the last thing you might consider is big data. There's a project codenamed Isotope that essentially brings Hadoop capabilities to Windows Azure. And you can take a look at that. So if you've got a lot of big data that you want to process, you might use Hadoop within Windows Azure as a backend for that. And so there's a whole bunch of other things here as well, along with things like caching and so forth that might be leveraged. So take a look at some of the other application building blocks. I said that I would tell you where you can go to get some more information for other platforms. There's toolkits that you can use for iOS and Android. Really, I think the easiest way is just to do a search on Windows Azure and iOS or Windows Azure and Android on some search engine. You will find it. These are all available up in GitHub, and they're all native libraries. So if you're doing iOS development, you can use Objective-C and Xcode. If you're doing Android, it's Dalvik bytecode, Java, whatever you want to call it, along with Eclipse tooling. So that's the easiest way to get up and running and doing exactly what I did here today for Windows Phone, but on those other platforms. So that's it. So as you build these mobile apps, consider storage, identity, different ways of communicating with your app, and definitely take a look at some of the additional platform services that come with Windows Azure. The last thing I will ask is that you take the time to submit some feedback. We would really appreciate it. I am very sorry about the wireless and some of the networking problems. Now you know why it's so important to build your apps on the phone so that they can run without network access as well. We didn't actually cover that, but that should actually maybe be a fifth point, is how to build these client apps when they don't have access to the internet. So thank you guys very much. I hope it was useful. You learned something and that met your expectations. Thanks.